Hello, everyone. Welcome to the fourth recording of Management 202. Right. So in this slide, we're going to talk about one thing that we assumed always known in the previous lectures, which is the discount rate. Okay, so remember when we talk about net present value, right, in the capital budgeting before, we estimated the cash flows C0 from to Cn, right, for each period using the formulas below, right? We explained that. However, we didn't really explain where we end up with the estimate for the discount rate R, right? So in the later slides, we're going to explain how we're going to arrive at the estimate for discount rate that we're going to use to value the net present value for investment projects, right? So the big picture of this topic is like this, right? So in the end, we are hopefully going to reach an estimate for the cost of capital of a firm, right? And we're going to use the cost of capital for a firm as the discount rate for the project. Okay, so here you might have a question that, right? So why would the cost of capital of a firm be equal to the cost, the discount rate of a project, right? We will answer that, right? But so far, right, if we look at the cost of capital of a firm, then it's basically average, right? Weighted average cost of capital, which is WACC over here, right? Is weighted average of cost of equity, R of E, and cost of debt, R of D. Okay, so it's called a weighted average because we're going to assign different weights on cost of equity and cost of debt. Okay, so the weight we're going to assign on cost of equity is E, which is market value of equity, divided by the market value of equity, E, plus the market value of the debt, D. Okay, and for cost of debt, we're going to have one additional term, which is 1 minus TC over here, right? So TC here means the tax rate, okay? So the reason we're going to have a 1 minus TC here on cost of debt is that we are trying to account for the tax benefit, which by financing through debt, we can, get for the firm, right? Because remember, if we finance through debt, we'll need to pay interest payments, right? Before we calculate tax, right? And the higher interest payment we pay, the lower tax we will have, right? So in this way, the effective cost of debt is not as high as its original cost of debt, right? So we need to apply 1 minus the tax rate over here to adjust for the cost of debt. And then we're going to assign the weight, right? Very similar with what we have assigned for equity, right? So the only difference here is the numerator, right? So instead of the market value of equity, here for cost of debt, we have its corresponding part, which is the market value of debt divided by the same thing, which is E plus D. Okay, so this is basically the final answer we're trying to reach. That's basically an estimate for the cost of capital, right? For the overall cost of capital for a firm, right? Constructed by cost of equity and cost of debt, right? With each of their own weights, right? So how do we think of a cost of capital, or cost of debt capital and cost of equity capital, right? What does it mean by the cost, right? So you can think of cost of debt as the amount of return that is required by the bondholders or the debt holders, right? So that they're willing to invest in the firm. Okay, so in order to induce investors to lend money to your company, you need to provide them with a return, right, on their investment. And for cost of debt is very straightforward, right? So if the company finances through corporate bonds, then the bonds yield to maturity is a very good estimate for the rate of return required by the bondholders. And we can use the yield to maturity as an estimate for R of D, right? However, it's not that simple for cost of equity, okay? So not like bond, whose yield to maturity is relatively, stable. The cost of equity, right, or the stock returns for a company is quite unstable. It's very volatile, right? So here we're going to need another method, right, to calculate cost of equity, which is what we call capital asset pricing model, right? And we can also use the constant dividend growth model, which we have talked about before, right? Basically assuming a stock as a perpetuity that pays constant dividends forever, right? Which is CDGM model, right? So these two models are going to help us determine the cost of equity, right? The cost of equity, and we're going to explain how we're going to use these two models, or how we're going to understand these two models, right? In terms of estimating cost of equity, right? So if we know each part, right, of the WACC formula, then it's very simple to find the overall cost of capital, right? So for example, if we have a company that has $1 million equity, right, $1 million debt, a cost of capital, a cost of equity of 10%, a cost of debt of 5%, and a tax rate of 40%, right? Then we can just directly plug in the numbers, right, to arrive at a 6.5% of WACC, right? So the calculation is actually very straightforward, right? So the main part, right, the most of the time we're going to spend in the next two lectures, right, is going to be on cost of equity, okay? So this requires a very good understanding on risk and how to estimate risk, especially equity risk for a company, right? And we're going to talk about diversification. We're going to talk about CAPM, right? And we're going to talk about how we're going to solve for this cost of equity. Okay, so this is the big picture, okay? And the question we didn't answer, right, when we first look at WACC is that, is it fair for us to set the project discount rate equal to the firm's discount rate, right? So the first assumption we're actually making when determining the discount rate over here is that if we use the WACC, which is the cost of capital for a firm, as the discount rate for the project, then for a company like Tesla or Dropbox that engages in very similar projects, it might be fine, right? It might be okay, right? Think about Tesla, who just produce electronic cars, right? Very very simple not very simple project, very standard projects, right? And although there are different models of electronic cars, but they are very similar in the nature, right? Dropbox provides online platform, online storage services, right? So although it's somehow different between providing the service to individuals like us or to companies, but the nature of that, that project is very similar, right? However, on the other side, you have conglomerates with many different divisions investing in many different projects, right? Like General Electronics, like Apple, like Procter & Gamble, right? So for example, Procter & Gamble not only produces shampoos, but also produces drugs, right? Which could be very different in its investment nature, right? So for those conglomerates, it might not be very fair to use the overall company's cost of capital as the discount rate for a specific project, right? So what should we do then, right? What should we do then, right? So one way to take care of this issue is that, for any type of project that these conglomerates are going to engage in, right? We want to find a company that only engages in such projects, right? And we can borrow the cost of capital from that company as the cost of capital or as the discount rate for the project that this conglomerate is taking. Okay. Okay. So for example, if Procter & Gamble is thinking about investing in a drug, right? A new drug. And but Procter & Gamble, they have so many projects, right? So its overall cost of capital may not be a very good estimate for the new drug project, right? So what Procter & Gamble can do is that, find a pharmaceutical company that only produces, a similar type of drug, right? And use the cost of capital from that pharmaceutical company as the discount rate for its own drug project. Okay. Think about this, right? Think about this. This is one way to figure out the problem, right? So another assumption that we're using, right, we're basically using for the WACC formula is that we're going to assign a weight which are quite constant over the investment project's life. Okay, so remember the weights we assign to equity, right? Assigned to cost of equity, it's E over D plus E, right? And E over D plus E is going to be constant throughout the investment horizon, okay? Which is a very strong assumption actually, right? There are many circumstances, and it's very likely that the companies may change on the financing, right? The financing from debt or financing from equity throughout the investment horizon, right? So remember, right, when we're using WACC as the discount rate, we're also making this assumption, right, which is very likely to change, right? So one thing we can do to fix it is that we can think about this WACC. Always think about this WACC as a time varying number, right? So in different years, right, if we can forecast that the company is going to increase its leverage or decrease its leverage, then we can incorporate that change into its time varying cost of capital, right, to adjust for this change in its leverage, right? And it's unlikely the final one, but another important assumption, right, we're making in using WACC for a project's discount rate is that we're assuming that there's no financial distress influence on the project value, right? So remember, when we first talk about estimating cash flows, right? I said that when estimating the cash flow for an investment project, we do not think about the interest payment, right? Meaning that we assume the company is solely financed by equity, right? So similar idea here, right? So here, the concept of financial distress is basically that when companies have borrowed too much and face the risk of not being able to pay it back, then it might have a large influence or a large influence on the projects it can take in the future, right? So here, we're essentially assuming that no matter how much the company has borrowed, right, it will not affect the project value, meaning that the financial distress should not be incorporated in the discount rate that we use for the project. Okay. So the goal of this slide is to basically explain these three ideas, right? So first of all, we want to have a good understanding on discount rate. And then we want to think about what determines discount rate, which is basically risk, okay? And how do we understand this risk, right? And finally, we want to know how to measure risk, right? What's a numerical way to quantify the risk so we can compare it across different firms, okay? And particularly for equity risk, right? How do we measure equity risk, right? We're going to use the past stock returns and the statistics to measure the equity risk. Okay. So first, discount rate, right? So discount rate so far may not be very everyone may be familiar with discount rate, right? It's the rate that we use to discount future cash flows, right? So we've talked about these two examples before, SpaceX and Coca-Cola, right? Which one has a higher discount rate, right? So of course, the one with a higher uncertainty, right, on its future cash flows. So SpaceX is likely the one that we are going to assign a higher discount rate with, right? It means that for an investor who is willing to invest in SpaceX, right, SpaceX needs to provide a higher return for their investment so that it can compensate the risk that this investor is going to take, right, for their investment. So, people generally have a very good instincts on risk, right? When they compare different investment projects. So here in the finance context, right? How do we understand risk, right? We know that SpaceX has higher risk than Coca-Cola, but what does higher risk mean, right? Is risk equal to danger, right? So in fact, in the finance context, right? So risk simply means that future reality may be different from our current expectation, right? So here, we want to understand risk as uncertainty instead of something bad is going to happen. Okay, so in the finance context, risk is a neutral word, right? It means both the upside and the downside, right? So it's like tossing a coin, right? So you have the probability of both reaching a head and reaching a tail, right? So a pitfall in understanding risk is always to think about risk as, the probability of, bad things happening, right? For example, the likelihood that stock price is going to drop, right? The likelihood that someone is going to lose money on their investment, things like that, right? So I want to highlight that this is incorrect, right? This is an incorrect way to understand risk, right? So another way to say it is that if you know something bad is going to happen for sure, then there's no risk. Okay, so think about this for a while, right? If something bad is going to happen for sure, then there's no risk. Okay, so here risk basically means uncertainty, right? At least in the finance context, right? Just means uncertainty. It could be uncertainty for good, it could be uncertainty for bad. Okay, so how do we measure risk, right? If we now have a better understanding of risk, which is basically uncertainty, or the likelihood that future might be different from our expectation, right? So think about it, this example, right? So Mike and his students are betting on $5 on a pro darts game. Okay, so throwing the darts on the board, right? And there are three players, Jack, Jane, and Jason. Okay, these three are competing for the championship in the game. And based on the previous performance of these three, they all have an average score of 17 out of 20, right? So the highest score you can get with one dart is 20, right? And they have an average of 17 out of 20, which are basically very good, right? They have the same past average performance, okay? But they have sort of different error margins, okay? So for Jack, his throws basically keeps him within plus and minus 2 points of his average, right? Meaning that most of Jack's throws is basically within the range of 19 and 15, okay? For Jane, it's between 15.5 and 18.5, okay? It's a slightly narrower margin than Jack. For Jason, it's wider, right? It's 2.5 plus minus 2.5, meaning that it is very likely that a throw from Jason, the next throw from Jason, lies within the range between 14.5 to 19.5, right? A slightly wider range, right? So if I'm betting $5 on one person, who should I bet on? Right? Who should I bet on? Right? So this is a different way, or a slightly different way of thinking about risk, right? So if I bet on Jack, then the next throw of these three people, or the result of the game, right? For Jack, he's going to probably reach 15, right, which is the lowest one. But on the upside, he might reach 19, right? For Jane, on the lowest side, she will reach 15.5, right, which is higher than Jack, right? But the upper side is also smaller than Jack, right? And finally, Jason is really wide, right? So he can reach as low as 14.5, which is pretty bad. But he also can reach somewhere around 19.5, which is almost the highest score that they can reach, right? So what does this mean, right? It basically tells us the expectation for these three people are the same, right? The expected score or the expected points from these three people are the same. However, we need to have a different margin, room of error for these three people, right? The outcome of these three people is going to be most volatile for Jason and least volatile for Jane, right? So which one should I bet on, right? If I'm betting on these three people, I will probably bet on Jane, right? And I'm sure that many of you will bet on the same one, right? Why is that, right? The reason is why is that, right? So one of the reasons is that people tend to hate risk. Okay, people hate uncertainty, right? So for something that has the same expectation, people will generally assign a lower value for the one that has a higher risk or has a higher uncertainty, right? So this is the logic for the risk pricing or for the valuation for many type of assets. Okay, because people hate risk, then they tend to assign a lower value on the assets that has a higher volatility, right? And if you do that in this case, right, our preferred player will be Jane, right, which has who has the lowest error margin, right? Because we're more certain that Jane is going to reach a 17 out of 20 points because she used to perform with the lowest volatility or the lowest fluctuation on her performance, right? So how do we quantify this? Is there a way to scientifically document this error margin, right? So in statistics, right, we have something called standard deviation or sigma, right? So later on, I will use this sigma to represent standard deviation, right? So standard deviation is basically a way people use to account for the room of error or uncertainty, right? So interchangeably with volatility, fluctuations, or risk, right? So these words will be used interchangeably, and you will know that they all represent risk. Okay, so how do we calculate the standard deviation of a series of numbers, right? So one way to calculate this is as the following, right? So if we have three numbers, 15, 16, and 17, right? So we know that the average of these three numbers is 16, right? So the standard deviation based on a sample distribution. Okay, I will explain what sample distribution is, right? A standard deviation based on the sample distribution is that we're going to sum the square of each number's difference from its average, right? Divided by the number of these three numbers, which is 3 minus 1, right? We'll take 1 off from the total of 3 of them. And we're going to take the square root of the overall result. Okay, so in this way, basically 15 minus 16 is -1. The square of -1 will be equal to 1, right? 16 minus 16 is 0, right? Square is still 0, right? And similarly for 17 minus 16, we will get 1, right? And the denominator is 3 minus 1, which is 2, right? So 1 plus 0 plus 1, which is 2, divided by 2 is 1, right? So the square root of 1 is 1. Right. So here, basically, it tells us that for three numbers, 15, 16, and 17, right, we have pretty good confidence that a future number is going to lie around 16 by the error room of 1. Okay, so what it represents, right, what the standard deviation of 1 represents over here is that, we will be quite confident that, if another number pops up, it will lie around 16, which is the average of the existing three numbers by the error margin of 1, right? So basically 16 plus minus 1, right? This is how we think about this, right? So why do we take 1 off from 3, right? So if you learned standard deviation before, you probably learned that the formula is slightly different because instead of using 3 minus 1, well, what you learned before is that we should use 3 instead, right? So why do we subtract 1 in the denominator? This is because we're thinking about this series of numbers as a sample of the overall population. Okay, so this is sometimes the sample distribution is used when there's no way for us to account for the entire population, right? So think about if we want to get the, let's say, average income of all the citizens in the United States, right? Well, we sort of want to have a sense of how much people earn on average. Then we need to estimate basically the average income of all US citizens, okay? And there's no way for us to do that, right? Because there are just so many people, it's so costly to do that. So what we'll do is that we're gonna draw samples of people and use the average we get from the samples as an estimate for the entire population. right? So here, population basically means all the US citizens, right? And the samples means that the small group of people that we're going to draw from the population as a representative for the population, right? So in this case, right, if we are doing our experiments or if we're trying to calculate the statistics in this sense, right, we should use a sample statistics, which, basically will tell us to take one off from the total population, right, from T, right? So if we have a total number of T values, right, so in this previous example, T equals to 3, right, because we have 3 numbers over here, right? Then the denominator should be T minus 1 when we calculate the variance and standard deviation, right? So here are the 2 formulas, right? So mu here, right, the Greek letter mu here represents the mean, okay, which is an average of these T numbers, right? So it's a simple average, right? You add all the numbers together and divide it by T, right? And the sample variance is 1 over T minus 1 times the sum of all these squares, right? So each square represents the difference, right? The square of difference between each number and the average, okay? Okay, like how we calculate this variance here. And if we take the square root of the variance, right, we will arrive at sigma, which is the square root of sigma square, right? So sigma square is called variance, sigma is called standard deviation. Okay. So the reason again, right, for using T minus 1 is that because we only know a small part of the overall population, right? So we need to adjust the denominator by 1, right? And why do we adjust it by 1, not by 100, not by 1,000, right? Then it's a more difficult problem to show, right? So if you're interested, feel free to check out sample statistics or sample distribution online and see how they derive this formula for their sample variance. Okay, but if we take it as granted, right? So if we directly take it and try to use it, then the stock return in the past few weeks, right? Let's take an example, right? So if we get the stock returns for the past few weeks, here it's basically 5 stock returns in the past week, right? So let's say in the past Monday, we have a 0.5% stock return. On past Tuesday, we have 2.1, and on the past last Friday, we have negative 2.1. Right? So the sample mean is basically the sum of all these returns divided by 5, which is 0.38%, right? And the sample variance is, instead of 1 over 5, we will have 1 over 4 here, right? Which is highlighted in red, multiplied by the sum of all these squares, right? And the result will be 0.0002832, right? And if we want to calculate the standard deviation, we take the square root of this number, which is 0.01638, or you can write it out as 1.638%. Okay, and in Excel, right? So if you don't want to do it by hand or do it by calculator, you can do it in Excel, right? And the function to calculate standard deviation in Excel is called stdev.s. Right? So you will find 2 functions associated with stdev, which is standard deviation, right? There's one called .s, there's one called .p, right? And you want to know that .s means sample and .p means population. And we should use the .s because we're thinking about this as a sample statistics, not a population statistics. Okay, I will explain more about this right in the live session, and we will do some examples. And hopefully you understand this better. But so far, right, let's assume that we know these are the correct formulas, and this is basically one example of how to apply this formula into a real problem. Okay, so here, right, how do we end up with how do we get the stock returns for each day, right? So I'm going to show you here how we calculate the stock returns, right? So stock returns is basically, the difference in the stock price divided by the original stock price, right? So let's say you buy Apple stock at the beginning of today, right? So instead of using the open price, people often use close price, right? So basically, let's say Apple has a close price of 136 on January 21st, right? And has a 139 close price on January 22nd, right? So its daily return, right, on January 22 will be calculated as the difference of these two close price divided by the close price of the previous day, right? So it's 139.01 minus 136.87, right? Divided by 136.87, right? So, or you can write it out as 139 divided by 136 minus 1, right? Minus 1, right? So you will reach 1.56%, right? Which is the daily return on January 22nd. Right, and there are certain events that can complicate this estimation, right? So sometimes the stock will do a split, right? Meaning that if the stock splits if one share splits into two shares, then naturally the stock price will become half of it, right? And if you still use the half price to calculate returns, you will get a very large or very small return, right? Which is not correct, right? So sometimes the stock will issue dividends, and the stock price will be basically the original price less the dividend issued per share, right? And it also is not fair to use that price to calculate stock returns, right? So instead of directly using the open or close price, right, we want to use something called adjusted close price, right? And this adjusted close price is basically the close price after adjusting these events that could, potentially have an impact on the close price. Right, so let's take a look at Yahoo Finance for Apple's stock. Right, so this is Apple stock last Friday. And so here, this is the historical stock price for Apple from January 23rd, 2020 to January 23rd, 2021. Right, and during which you will see that there will be certain dividend issued on certain days, right? So on November 6, 2020, there's a 0.205 dividend issued per share, and also similar things on so there's actually a stock split happening on August 31st, right? So you will see that which is the open close price. This is the close price, right? So the close price, right? So after the split, right? After the split between 28 to 31, right? So without adjusting for the split, right, the stock price increases to 129.04, right? However, this last column is adjusted close price, right? Meaning that after adjusted for the stock split, the stock price should actually be around 128.82, right? So you will get a different return if you use different close price, right, to calculate its return. So my point is that when you do your case study, always use the adjusted close price, right? So let go of all these previous prices. Only use adjusted close price to calculate stock returns. Okay. So that's about how to calculate stock returns, right? So this is about daily stock returns, right? If you want to calculate monthly stock returns, right, use the adjusted close price at the end of each month, right? And similar for yearly returns, or even more than yearly returns. Right. So here is an example for the stock of Apple and the overall market return. Okay. So what we see here is that from 1982 to 2014, right, we see a very high return for Apple, right, in terms of average annual return as high as 34.6%, right, compared to a market return of 12.2%. Right. However, if you invest in Apple only instead of investing in the marketing portfolio, you're also taking a much higher risk than the market, right? You're also basically bearing a very high, a much higher volatility than the market, meaning that the stock can go either upside a lot or go downside a lot, right? So basically what it means is that with a pretty high probability, you could have lost, about negative, you could have made a loss with about negative 36.7% by investing in Apple, right? However, the downside, the extreme downside for investing in market is about 4.7%, negative 4.7%, right? So sometimes people always look on the upside, which is a realized return, right? However, you should also think about the downside that you could potentially also end up with when investing in individual stocks like Apple, right? So you're not only thinking about an upside of 34.6% positive, but also a negative downside of 36.7%, right, by investing in Apple, right? However, the loss could be much smaller if you invest in market portfolio, right? But the bad thing is that also the upside is also lower for the market portfolio. Okay, so this is basically a summary, right, for what we have talked about in this slide, right? So we explained the concept of, we explained the big picture of cost of capital, right? What we want to reach in the end. And we talk about how to understand discount rate of investment projects versus the cost of capital for a firm, right? And we explain that, the discount rate is basically determined by the risk of the company, right? And to measure the risk, we're going to, especially for equity risk, right? We're going to use the standard deviation of its previous performance, right? So for stock returns, we're going to use the standard deviation of the past stock returns, right? And we're going to try to assume a sample distribution, which, we're going to take one of the total number of observations that we're going to have, right? So instead of having t as the denominator, we're going to have t minus 1 as the denominator for estimating the variance, right? And then standard deviation will be the square root of the variance. Okay, okay. So so here, right? So here, one thing I want to point out is that this mean function is this is not the correct mean function. Mean function should be the sum of x1 plus all the way to xn, xt divided by t. All right, so this should be the mean function for mu. Okay, this should be the mean function for the mu. Right. So next, we're going to talk about how to determine the relationship, right, between discount rate or cost of capital with risk, right? Basically, how we can quantify the relationship between risk and cost of equity, right? And we're going to explain how diversification plays in the part, right? And we're going to explain how we're going to understand the capital asset pricing model for this part. Okay. All right. Okay. So the second part is, give me 1 second. Okay. So the second part is basically try to understand the relationship between returns and risk. Okay, so we know that we can quantify risk, right? From the previous part, we know that we can quantify risk as the standard deviation of stock returns, right? However, we're going to look at some examples of the actual relation between returns and standard deviation, and I'm going to show you why we cannot directly use stock returns as the estimate for cost of equity. Okay. So let's think about Apple stock. Okay, let's think about Apple stock. So Apple actually earns a stock return of 75% in the last in the past 12 months, right? So if we use directly Apple's stock returns as the equity, as the cost of equity, then basically we will have a cost of equity of 75%, right? So do you think it's a fair estimate for Apple's discount rate, right, I would probably think is way too much than the actual amount of risk that Apple has, right, on its equity, right? So how should we determine which number to use for its cost of equity, right? So let's take a look at example, right? So if we not only think about Apple, but also think about some other stocks, right? For example, Ford, right? Let's think about these two stocks together, right? So if we can invest in Apple, then in the past 12 months, we would have an average daily return of 0.27%. And if we invest everything in Ford, we will end up with a 0.16% on average daily return. Okay, and if we decide to do something different, right? Instead of investing 100% on, either stock, we actually break our investment, right, and invest 50% on Apple and the other half on Ford, right? So if we do that, we will get a return of 0.22%. Okay, it is lower than what we can get from investing everything in Apple. However, it's higher than what we can get if we invest everything on Ford. Okay, so let's not only look at the returns, right? Because as we said, right, people hate uncertainty, right? So let's also look at the uncertainty of this different investment, right? So if we invest in Apple 100%, then we're going to have a standard deviation on the daily returns of as much as 2.98%. Okay, and if we do that, do the same on Ford, we're going to end up with a 3.66% on Ford, which is even higher than Apple. Okay, which is even higher than Apple. And if we do half and half, we will get a 2.81% as the standard deviation. Okay, which is smaller than both Apple and Ford's standard deviation here, right? So what does that mean? It means that actually, if you can combine these two investments together, you will reduce the risk for each of them, right? You will reduce the risk for each of them, right? So that the combination of them has a smaller variation, right? Or has a smaller risk than each of them, right? Or than either of them, right? But the downside is also that after combining both stocks, we will reach a lower return, right? We will reach a lower return, right? So it basically tells us two things, right? It tells us two things, right? So first thing is that, higher risk does not necessarily mean higher return, right? So for example, look at Ford, right? Ford has a standard deviation that is higher than Apple, right? However, it has an average return which is lower than Apple, right? So if higher risk means higher return, then with the higher standard deviation on the daily returns, Ford should have reached a higher return, higher average return than Apple, right? But the reality is the opposite, right? So basically, the first thing that we learn here is that higher risk does not necessarily mean higher return, right? And Ford in the past 12 months is a perfect example, right? And the question is why, right? So isn't that our something that we always understand is true, right? Higher risk, higher return, right? Don't people always say that, right? We're going to explain why this is not always true. Okay, and the second thing we realize is that actually people have a certain ability to reduce risk if they want. Okay, so if we only look at one asset, Apple, then there's not much we can do. However, there are plenty of assets or plenty of stocks in the stock market, right? By combining certain stocks together, we can actually reduce the amount of risk that we're going to take, right? We're going to face by investing in individual assets, right? So although the average return may be lower, but we also will have lower risk, right? And sometimes people will prefer assets with lower returns and lower risk, right? Because this is basically their preference, right? Remember, people hate risk, right? People hate uncertainty. So sometimes some people will like will be okay if the return is lower when the risk they take is also lower, right? So let's talk about why high risk does not necessarily translate into high return. Okay, and the answer is that there are different types of risks. Okay, there are two types of risk in general. One type is called systematic risk, right? And some other words, which is interchangeably used with systematic returns, systematic risk is market risk or undiversifiable risk, right? And there's a second type of risk that we often call idiosyncratic risk, right? You can also say diversible risk or unsystematic risk, right? Unsystematic risk as a similar word to describe idiosyncratic risk, right? But if you try to understand the meaning of these two words, right? Systematic risk is basically says, this is something in the overall system, right? This is a risk that's contained in the overall system, and if as long as you're in the stock market, there's no way for you to avoid it, right? There's no way for you to diversify it away, right? Idiosyncratic, on the other side, means that it's firm specific, right? It's something that only happens to one firm, but has no impact on the other firms, right? So this is why it's called idiosyncratic, right? So some examples is like this, right? So think about the following examples, right? So Steve Jobs' death will lead to Apple's losing its creative edge, right? What risk is this? Is it an idiosyncratic risk or is it a systematic risk, right? So Steve Jobs is Apple CEO, right? So Steve Jobs, the loss of Steve Jobs is going to affect Apple, right? Instead of other companies like Samsung, right? So it is more of an idiosyncratic risk for Apple, right? So second example, there's a risk that GE's diversified business structure will cause GE to be incompetent in some of its business segment, right? So is this related to other companies at all? Not really, right? So it's an example of idiosyncratic risk, right? And the last example, the COVID crisis can lead to a recession causing Apple sales to decline, right? So does the COVID crisis only impact Apple, right? It will also impact its competitors and all the other firms, right? So it's something that's affecting the overall market that not really any companies can avoid, right? So this is what we believe as example of systematic risk, right? So this is basically how we understand the two different type of risk, right? So for idiosyncratic risk, it happens to specific firms, right? Meaning that sometimes there are some firms who have some positive news, and some other firms will have negative news, right? So if you invest all the firms together, these effects tend to cancel out each other, right? But for systematic risk, right, it applies to the entire market, and as long as you invest in anything which is in the same market, then there's no way to avoid it, right? So that's called systematic risk. Okay, so two examples of systematic risk. So what will happen if we sort of increase the number of stocks that we hold in our portfolio, right? So let's suppose we only hold Apple. Then the loss of its CEO, right? The Apple's own business structure will have a lot of impact on our investment returns, right? However, if we add Samsung into it, then it's going to be a weaker effect, right? And if we add more and more stocks into our portfolio, then we will have more companies who are doing good, and we'll have companies who are doing bad, right? So they basically cancel out each other's idiosyncratic risk, right? So this is what we're gonna see, right? So with the increasing amount of investment in our portfolio, we're gonna observe a decreasing amount of idiosyncratic. We're gonna observe a decreasing amount of idiosyncratic risk from individual stocks, right? Because in the end, a lot of them will be canceled out by other stocks, right? So the green part, which is the above, right, which is the green part above here, means the amount of idiosyncratic risk, which is decreasing when our portfolio increases, right? And however, there's a part of systematic risk we can never, get away with, right? We can never get away with, right? So this is basically what diversification tells us, right? We can diversify only the idiosyncratic risk, but not the systematic risk. Okay, so how does that affect our understanding on the relation between returns and risk, right? So essentially, right, we're trying to think about a way to figure out how to estimate cost of equity, which is in terms of the degree of risk right? So if we have two parts, right, systematic risk and idiosyncratic risk, then we cannot directly use the total risk that we can estimate by using the standard deviation of stock returns, right? So remember, when we estimate the standard deviation of Apple stock returns, it represents the sum of two type of risks together, right? So if we only care about systematic risk and not care that much about idiosyncratic risk anymore, then we cannot directly use the standard deviation of stock returns, right? So somehow, maybe it will be helpful for us if we can find a portfolio that only contains systematic risk. Okay, so what is an example of a portfolio that only contains systematic risk, right? It's basically the portfolio that we will end up with if we, include all type of assets in our market, right? Let me repeat it. What will be a good portfolio that only contains systematic risk, right? It will be a portfolio basically when we include every type of asset that we can in this market, right? So what kind of portfolio is this? A market portfolio, right? A market portfolio. So SP500 is a proxy for a market portfolio because it basically contains over, I don't know, like 95% of the entire, market, entire stock market, right? So sometimes we use SP500 as a representative for market portfolio that only contains systematic risk, right? Or contains a very, very small part of idiosyncratic risk, right? So here is the reason, right, why we use market portfolio as a portfolio that only contains systematic risk, right? And how is that going to help us, reach the result for our cost of equity, right? So basically, here's what capital asset pricing model says, right? By measuring how sensitive a stock co-moves with the market portfolio, right, we can determine the amount of systematic risk contained in that stock. Okay, so we cannot directly see how much systematic risk is contained in a stock. However, if we know how sensitive a stock co-moves with the market portfolio, which only contains systematic risk, then basically we can find the amount of systematic risk contained in that stock. Okay, so this is the logic of CAPM. Okay, so basically, in terms of a formula, this is what CAPM says, right? So the expected return for individual stock, right, minus the risk-free rate should be equal to the sensitivity of that stock multiplied by the expected return of the market portfolio less the risk-free rate. Okay, so here we have another phrase to introduce, right, which is called premium. Okay, so risk premium. So here, the RM less RF is called market risk premium, right? It's the market return less the risk-free rate, right? For example, like saving in a bank or investing in treasury bills, right? And similarly, RI minus RF is what we call individual stocks risk premium. Okay, so basically this formula tells us, there should be a linear relationship between a market risk premium and individual stocks risk premium. Okay, and that relationship is characterized by a coefficient called beta I, right, which is the specific stock's sensitivity, right, relatively to the market risk premium, right? This beta here measures how this individual stock returns co-moves with the market returns. Okay. This is basically what CAPM says, right? It's quite straightforward, right? So the underlying logic is that, first of all, we know that there are two types of risk, right? Systematic and idiosyncratic, right? And the idiosyncratic risk should not be translated into returns because investors can diversify them away. Okay, so it's the systematic risk that only accounts for the amount of return that or the amount of cost of equity that a company should have. Okay, and so if we know the relationship between the cost of equity, right? The cost of equity of a firm and the cost of equity and the overall market risk premium, right? Which is defined by the beta. Then we can comfortably, represent, right? Or we can comfortably estimate this expected cost of equity as, RF plus this right-hand side of the equation, right? So now the focus is on this beta, right? How do we find this beta? If we know beta and we have an estimate for market's future return, then we basically will have an estimate, right, for the company's cost of equity, right? So here the issue, right, a central issue is how do we come up with a beta, right, which measures the sensitivity of stock returns movement with the market return, right? So here, right? So let's do a simple example, right? So if the beta equals to 2, right, it means that the stock return, right, or the stock is twice as risky as the market portfolio. Okay, if a market portfolio has amount of risk, then a beta I of 2 means that the stock is basically twice as risky as the market return, right? Contains twice as much of the systematic risk contained in the market portfolio. Okay, so let's do an example here, right? Let's say a firm has a beta of 1.5, right? And a 3-month treasury bill pays an APR of 1%, right? We can think of this 3-month treasury bill as estimate for risk-free rate, right? And the SP 500, which is the market portfolio, is expected to deliver a 5% return, right? Which is sort of like the average historical return for SP 500. And according to CAPM, what should be the expected return for firm A, right? So the expected return for firm A should be RF plus beta times, the difference between RM and RF, right? So which is 1% plus 1.5, which is beta, times 5% market return estimate minus 1% risk-free rate, right? So 1.5 times 4 plus 1 will be 7, right? Which is the expected return of firm A. Okay, so this is another example which you can take a look at yourself. Okay, so how do we determine beta, right? Here, right, some other complicated formulas, right? But don't be afraid, right? I will not require you, right, to use this formula, right? But what you want to understand is that beta comes from the historical data of the individual stock returns and the market stock returns. Okay, so if we have a sample period that tells us how this individual stock return has performed in the past sample period, along with the market return, and so we can calculate a covariance between these two, right? And if we use this covariance of these two divided by the variance of the market return in the past sample period, we can get this estimate for beta. Okay, and if we have beta over here, then we can directly apply to a CAPM formula like this to estimate the stock return, the expected stock return. Okay, so this is how we estimate beta, right? So this beta, right? This beta is also called the risk loading, right? So think about this equation here, right? Essentially, this is the market risk, right? This is the firm's risk, right? This represents firm's risk, right? Beta is called risk loading, basically meaning that this is the amount of risk that this individual stock loads on the market portfolio. Okay, so how are we going to estimate beta if we know the past or the historical returns of both RI and RM, right? We're going to use Excel to calculate this. Okay, so the way we're going to calculate this is like this, right? So for example, we're trying to figure out Dropbox beta, right? We're trying to figure out Dropbox beta based on past, a month's daily returns in January and February and March, right? So let's use 3 months daily returns from Dropbox and 3 months daily returns from market portfolio or SP 500, and the risk-free rate to determine the cost of equity or to determine the expected return for Dropbox, right, in the future, right? So we will have this data on Dropbox daily returns, on market daily returns, so that we can actually estimate the covariance of this two series of data returns, and also the variance of the market returns, right, over the past 3 months, right? And we divide the covariance, right? We divide the covariance with from the variance, right? We divide the covariance. Oh, sorry. We divide the covariance, right? COV.S, a sample covariance, right, by the sample variance of market risk premium, so that we'll get a beta of 1.39, right? So this is the beta of Dropbox, right? So cost of equity for Dropbox will be beta times the market risk premium, which is 5% less 2.4%, right? Which is, you know, the 3 months risk-free rate, plus 2.4%, which will be around 6.01%, which is the cost of equity for Dropbox. Okay, we will show the real example, right, in the live session. You know, just to show you how to calculate beta and calculate cost of equity, right? So this, you will need to be able to perform this task yourself in the quiz and also in the case project. Okay, so if you describe the cost of equity as E of R, right, in terms of risk-free rate and market risk premium, right? And if we think if we increase beta, right? So if we increase beta, we will also see an increase on the left-hand side, which is the stock return, expected stock return, right? So this is basically like a graph representing the linear relationship between cost of equity and beta, right? So when beta increases, cost of equity also increases, meaning that the amount of risk contained in this individual stock is higher because we have a higher beta, right? So when beta equals to 0, basically this left-hand side will be equal to RF, right? So if we are looking at just the treasury bills, which has no, you know, covariance, or which has no relationship with the market portfolio, then setting beta equal to 0 will give us the risk-free rate, which is about 2.5 or 3% over here, right? However, if we're looking at a stock like Boston Beer, who has very close, or who has a beta very close to 1, then it has you know, a return around 8%, right? For Apple, who has a cost of who has a beta about 1.5 or, you know, 1.3 over here, right? Apple will have a cost of equity about, you know, 11% over here, right? And Ford, which is riskier than Apple, right, has a beta of, you know, 2.2 or 2.1, something like this, right? And Ford will naturally have a higher cost of equity, which is about 16% over here, right? So this is how we estimate cost of equity using CAPM, right? And the central part of CAPM is to find beta for each stock, right? And to find beta, we need its historical returns along with the market historical returns, okay? And that's basically the steps that we need to take to find cost of equity using CAPM, right? So how good is the CAPM performance in reality, right? Because the theory sounds very, you know, very sound, right? How is the empirical evidence for this model, right? So it works pretty well for most of the stocks. However, you know, it does not work very well for particularly small firms and you know, firms with a certain type of characteristics. Okay, so it means that, you know, for the majority it works pretty okay, but for some particular stocks, it doesn't work that well. Okay, so this leads to you know, further discussions on how we can improve CAPM, right? So Fama French has, you know, a factor model, right, including three factors, right? And you know, recently they introduced like 5-factor models, right? And then people have different ideas on what should be included in these models, and they each have their own reasons on how this model should perform, you know, relatively to CAPM and to existing models, right? And so that's basically what academia cares about recently, and also many investment institutions also use these models to you know, determine the investment strategies, right, to decide which portfolio they should take. So even though CAPM does not work as well as it is believed, many companies, right, so like what Graham Graham and Harvey 2001 have shown, right? Many CFOs still use CAPM as sort of like a benchmark for the estimation for cost of equity. Okay, so I think that's so much for estimating cost of equity, right? So to sum up, right, we talk about the benefit of diversification, right? You can use the Apple Ford example as a way to see how we can reduce the risk of our investment by diversification, right? Meaning that allocating different amount of our investment or capital into different type of assets, right? And we didn't really talk about the mean returns and variance of portfolios. We didn't really talk about efficient frontier, right? So we skipped this part, but we did explain what is systematic risk and idiosyncratic risk, right? And then we come up with a measure for pure systematic risk, which is to use the market portfolio. And then we talk about the logic of CAPM that can give us an estimate or a good estimate, a reasonable estimate for cost of equity, right? Okay, so that's it. I'll see you in the live class. We'll do some practice in the live class. Thank you. Bye-bye.